Hello my scholars, this is my Myschool YouTube channel and my name is Frank. In today's video, we shall be tackling JAMB CBT physics past question for the year 2001. So relax, do not go anywhere and we'll be right back. You are welcome back to my Myschool YouTube channel. In today's video, we shall be answering question 26 to 50. So let's kick off with question 26. The particles emitted when krypton 39 decays to krypton 39 is, so A we have gamma, B we have beta, C we have electron, and D we have alpha. So if you look at the krypton before it decays to the product when it decays, you find out that there is no change in atomic number and there is no change in mass number. Okay, so that indicates that what was emitted is actually neutral. Okay, so that makes option A the correct answer to this question. Now if you check the rest option, if any of these were emitted, then there will be either change in the mass number or change in the atomic number, or both. For example, in the case of alpha particle, if for example alpha particle was what was emitted, then there will be change in the mass number and there will also be change in the atomic number. But in this case, there's no change in the atomic number and there's no change in the mass number. So that makes option A the correct answer to this question, gamma. Question 27. I, low pressure, II, high pressure, III, high potential difference, IV, low potential difference. Which combination of the above is true of the conduction of electricity through gases? Okay, so the combination of the above that is true for the conduction of electricity through gases is actually low pressure and high potential difference. Okay, that is I and III. Okay, now the essence of low pressure is that low pressure reduces the density of gas particles, allowing for free movement of electrons, and the high potential difference ionizes gas molecules, creating charged particles that enables current flow. Okay, so that makes option B the correct answer to this question. Question 28. The current through a resistor in an AC circuit is given as 2 sine omega t. Determine the DC equivalent of the current. So let's move to the board to provide answer to this question. So the current in the circuit was given to us to be equals to 2 sine omega t. So we are going to compare this with I is equals to I naught sine omega t. So in this case, we can say, if we compare, we can say that I naught, which stands for peak current, is equals to 2 ampere. But remember that there's a relationship between peak current and root mean square of an AC circuit, right? So the relationship is that I RMS is equals to I naught all over root 2. But remember that this your current here, which is the root mean square current, actually represents the equivalent DC current that delivers the same power to a resistive load. Okay, so that is the reason why we are calculating this. So whatever we are going to get here is equals to the DC current that we are asked to calculate for, right? So let's just substitute. So you're having 2 all over root 2. Of course, we have to rationalize the denominator of this fraction, so that at the end of the day, our answer becomes root 2 ampere. Okay, so let's return back to the screen to pick the correct answer to this question. So, and that is option B, root 2 ampere. Question 29. The primary coil of a transformer has N turns and is connected to a 120 volts AC power line. If the secondary coil has 1000 turns and a terminal voltage of 1200 volts, what is the value of N? So let's return to the board to provide answer to this question. So just take note of this, that for a transformer, okay, voltage is directly proportional to the number of turns, right? So in this case, we'll be having Vx over Vp is equals to Nx all over Np, okay? Where Vp stands for voltage in the primary coil, while Vs, voltage in the secondary coil, number of turns of the secondary coil, number of turns of the primary coil. So in this case, we are looking for Np, right? So we just make it the subject of formula, so that Np will be equals to Vp times Nx divided by Vx, right? So let's substitute the values that are given to us from the question. So our Vp is 120, then times our Ns is equals to 1000, then divided by our Vs, which is 1200, right? So zeros, we take out zeros. 12 here is 1, while 12 here is 10. So that at the end of the day, we are now having 10 times 10 left, and 10 times 10 is equals to 100, okay? So that means the number of turns of the primary coil is equals to 100 turns. So let's return back to the screen to pick the correct answer to this question, and that is option B, 100 turns. Question 30. Which of the following metals will provide the greatest shield against ionizing radiation? So option A, we have iron. Option B, we have manganese. C, we have aluminium. And D, we have lead. Okay, so the answer to this question is actually lead. Lead is highly effective at shielding against ionizing radiation because of its high density and atomic number. Okay, so that makes option D the correct answer to this question. Question 31. The process of energy production in the sun is A, we have nuclear fission. Okay, so nuclear fission is the process whereby a heavy nuclei splits into smaller nuclei, okay, releasing energy in the process. While option B, we have nuclear fusion. Okay, so in nuclear fusion, actually two smaller nuclei come together to form a bigger nuclei, okay, with the release of tremendous amount of energy in the process. While option C, we have electron collision. You're just talking about the interaction between electron and other particles. While option D, we have radioactive decay. So radioactive decay is the process whereby unstable atomic nuclei loses energy by simply releasing radiations. Okay, so the answer to this question is nuclear fusion. Okay, so in the sun, hydrogen nuclei combine together to form helium, releasing a tremendous amount of energy in the process, and this is the process of energy production in the sun. Okay, so that makes option B the correct answer to this question. Question 32. At resonance, the phase angle in an AC circuit is, so A, we have 90 degrees, B, we have 60 degrees, C, we have 0 degree, and D, we have 180 degrees. So at resonance, basically the capacitive reactance is equal to inductive reactance. So at that point, the phase angle is actually equals to 0 degrees. Okay, so that makes option C the correct answer to this question. Not A, not B, not D, but option C, 0 degree. Question 33. The force on a current carrying conductor in a magnetic field is greatest when D, A, conductor makes an angle of 60 degrees with the field. B, force is independent of the angles between the field and the conductor. C, conductor is parallel with the field. D, conductor is at right angle with the field. Okay, so going by this formula, the force on a current carrying conductor in a magnetic field is given as F is equals to BIL sine theta. Okay, so let's assume that these three variables are, for example, is equals to 5, right? So let's just assume that it's equals to 5, like we have the values and we multiply them together and it's equals to 5. Now, if we have any angle here, okay, that is less than 90 degrees, you are going to discover that what you are going to look for the sine of that angle is going to be less than 1. Okay, but if we have theta here to be equals to 90, then the sine of that 90 degree will be equals to 1. So at that point, we are going to be having maximum value. Now remember that angle 90 degrees simply means that two lines are perpendicular to each other, right? So in this case, the conductor is at right angle to the field, right? So we can conclude that the force on a current carrying conductor in a magnetic field is greatest when the conductor is at right angle with the field. Okay, so that makes option D the correct answer to this question. Question 34. A transistor function mainly as a dash. So A, we have switch and amplifier. B, we have rectifier and an amplifier. C, charge storer and an amplifier. D, charge storer and a switch. So transistor is a versatile component used in electronic circuit, but the main function or a transistor is mainly used for two purposes. One, to serve as an electronic switch and also as an amplifier. Okay, so that makes option A the correct answer to this question. The transistor functions mainly as an electronic switch and amplifier. Question 35. Energy losses through eddy currents are reduced by using A, low resistance wires, B, insulated soft iron wires, C, few tons of wires, and D, high resistance wires. So eddy current is one of those energy losses in a transformer, and eddy current are usually reduced using insulated soft iron wires. Okay, so the import of this insulated soft iron wire is that they reduces electrical conduction and prevents the flow of current through insulation. Okay, so that makes option B the correct answer to this question. Question 36. A capacitor of 20 times 10 raised to power minus 12 farad and an inductor are joined in series. The value of the inductance that will give the circuit a resonance frequency of 200 kHz is. So let's move over to the board to provide answer to this question. So resonance frequency F0 is equals to 1 over 2 pi then root LC. Okay, where L stands for inductance, Y stands for capacitance. So first of all, let's make the L the subject of formula, because basically that's what we are looking for in this question. So to do that, we have to take the square root of both sides. So our F0 will be squared, so that here we'll be having 2 pi squared, right? Then this whole thing will cancel out. So this is what we have, because 1 squared is also 1. Right? So but since we want to make this the subject of formula, I think we just change position, that's all. So we just make, here we want to make L the subject of formula, so we just switch position, we just switch the position with that of the resonance frequency. Okay, so N will now be equals to 1 over 4 pi square then times F0 square then times C. Right? So let's put this in standard form. So if we put this in standard form, we'll be having 2 times 10 raised to power 5, right? 2 times 10 raised to power 5 years. And if I had to also put this in standard form, because this is not in standard form actually, so we'll be having 2.0 times 10 raised to power minus 11. Remember, we actually move 1 places from our left, from our right to our left. And when we are moving from our left, from our right to our left, we add 1 to the power. So in this case, we only move 1, we add. Okay, so we only move 1, so we are going to add 1 to this. So if we add 1 to minus 12, that will be equals to minus 11. Okay, so let's be seeing our value. So here we are going to take pi squared to be equals to, okay, to be equivalent to 10. Okay, so let's put in our value. So here we'll be having 4 times 10 for the pi square, then times bracket open 2 times 10 raised to power 5 in bracket square, then times the capacitance, which is 2.0 times 10 raised to power minus 11. Okay, so here we just have to tidy up things. Okay, so let's continue from this part. So our L is equals to 1 over, so here we see our 4 times 10, then times, so let's open up this bracket. So here we'll be having 4 times 10 raised to power 10. Remember your law of indices, okay? Then times 2 times 10 raised to power minus 11. So let's tidy up everything. Now this is the same thing as say 1 times 10 raised to power 1. So if we add all the positive powers together, we'll be having plus 11. And here we are having minus 11. So in that case, it's going to cancel out. So we'll be having just 0. And anything raised to power 0 is equals to 1. So we just multiply this. 4 times 4 is 16. Then 16 times 2 is equals to 32. So basically, this is what we are having. 32 times 10 raised to power 0. Because this 10 here is the same thing as 1 times 10 raised to power 1. Right? So the two powers we add together to give us 10 raised to power 11. But here we are having minus 11. So if we add together, in that case, we are having 0. Right? And anything raised to power 0 is 1. So that at the end of the day, our inductance is the value of our inductance is equals to 1 over 32. And remember, inductance is in Henry. Okay, so we'll now be having 1 over 32 Henry. So let's return back to the screen to pick the correct answer to this question. And that is option D, 1 over 32 Henry. Question 37. The magnetic force on a charged particle moving with velocity v is A, proportional to both the magnitude of the charge and the velocity v, D, independent of the magnitude of the charge, C, proportional to the velocity v only, and D, proportional to the magnitude of the charge only. So to answer this question, it's proper for us to write the formula for calculating magnetic force, and which is F is equals to Q V B sine theta. Okay, so where Q here stands for magnitude of charge and V here stands for velocity, while B here stands for the magnetic flux density. Okay, so from this formula we can see that the force F, the magnetic force F, is proportional, is directly proportional to the magnitude of the charge and also to the velocity, right? So that makes option A the correct answer to this question, proportional to both the magnitude of the charge Q and the velocity V. Okay, so option A is the correct answer to this question. Question 38. In the diagram above, which of the simple pendula will resonate with P when set into oscillation? So A will have T, B, U, C, arrow and T, D, Q and arrow. So by careful inspection of the diagram, okay, you discover that the length of pendulum P and that of pendulum T are the same. Okay, so when the pendulum P is set into oscillation, pendulum T will resonate with pendulum P. Okay, so that makes option A the correct answer to this question, since the length of pendulum P and that of T are the same. So when pendulum P is set into oscillation, pendulum T will resonate with pendulum P because they are of the same length, hence or therefore of the same frequency. Okay, so that makes option A the correct answer to this question. Question 39. The diagram above is a block and tackle pulley system in which an effort of 80 Newton is used to lift a load of 240 Newton. The efficiency of the machine is, now remember that efficiency of a machine is given as mechanical advantage all over velocity ratio times 100, right? But in the case of a block and tackle pulley system, okay, the velocity ratio is equals to the number of pulleys. So in this case we have 1, 2, 3, 4, 5, 6. So the value of the velocity ratio is equals to 6. Now here, from the parameters that are given to us, we can actually calculate for mechanical advantage, which is load all over effort, and these values are given to us. So let's move to the board to provide answer to this question. So we already know that our velocity ratio is equals to 6, right? And efficiency is equals to mechanical advantage all over velocity ratio times 100, right? But mechanical advantage is equals to load all over effort. We can rewrite this fraction, this part of the equation, to be equals to efficiency to be equals to mechanical advantage, which is load all over effort, then times 1 all over V dot R. So nothing changed, okay? This and this are still the same, times 100 all over 1. So now we can substitute the values that are given to us. So load is equals to 240 and effort is equals to 80 times 1 all over the velocity ratio, which is 6, times 100 over 1. So here 0 will take out 0, 8 here is 1, 8 here is 3, 3 here is 1, 3 here is 2, 2 here is 1, 2 here is 50. Okay, so at the end of the day, the efficiency of the machine is equals to 50%. So let's return back to the screen to pick the correct answer to this question, and that is option B, 50%. Do you know that you can take practice question with our simulated JAMB CBT past question? All you need to do is to click on the link in the description below, and that will take you to my school website. There you have to download my school mobile app for your Android devices and my school software for your laptops and computer. Please go ahead and start practicing. Moving on to question 40. If ray traveling in air is incident on a transparent medium as shown in the diagram, the refractive index of the medium is given as. So let's look at the diagram that is given to us. So take note that this angle of incidence and angle of refraction, as the case may be for this question, is actually measured with respect to the normal, and this is the normal. So if you look at this place carefully, the angle of reflection has been given to us to be equals to beta right? But the angle of incidence is not correct. So the angle of incidence is actually from the normal to where the ray entered into the second medium, right? So, but if you measure from here to here, okay, this is actually two perpendicular line, which is equals to 90 degrees. So to get what is left here, it will be equals to 90 minus alpha. Okay, but remember that n, the refractive index, is equals to sine I, which is sine of angle of incidence, all over sine of angle of refraction. But remember that our I, according to this question, is equals to 90 minus alpha, right? So let's just substitute, and here for our refracted ray is equals to beta. So let's substitute those values. So here we'll be having sine 90 minus alpha all over sine beta, right? But remember in your further maths, remember complementary angle, that if you have sine in brackets 90 minus alpha, that it is equals to cos alpha, right? So in place of sine 90 minus alpha, we'll replace it with cos alpha, so that the refractive index of the medium will now be equals to cos alpha all over sine beta, right? So let's go through the option and see the one that agrees with what we have done, and that is option A, cos alpha all over sine beta. So that makes option A the correct answer to this question. I believe you are enjoying this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos. Question 41. In the diagram above, the current I is, so let's move over to the board to provide answer to this question. So as we can see in the diagram, the 10 ohms resistor and the 5 ohm resistor, they are in parallel. So first of all, let's get the effective or the total resistance there first, okay? So that will be 1 over R effective will be equals to 1 over 5 plus 1 over 10, right? So if we solve this fraction, we'll be having 3 all over 10, right? So for us to get the effective resistance, okay, that will be equals to 10 all over 3 ohms, right? So this is what we got from calculating the effective resistance for the two resistors that are in series, right? Now this effective resistance is in series, okay, with the 1 ohm resistor and the 3 ohms resistor. So effective resistance in that case will now be equals to 10 over 3 plus 3 plus 1. So if we add these fractions together, our answer will be equals to 22 all over 3 ohms. Now that we have gotten the value of the effective resistor of that circuit. Now remember that V from ohms from Ohm's law, we know that V is equals to IR. But in the case of this question, we are asked to calculate for current. So we just make it the subject of formula. So that I is equals to V all over R. Right now in the question, the value of V is 6 ohms. So here we just put 6 all over 22 all over 3, right? So this will invert, so that at the end of the day we'll be having 6 times 3 all over 22. So 2 here is 11, 2 here is 3. 3 times 3 will give us 9 all over 11 ampere. Okay, so the value of the current in the circuit or the diagram that is given to us above is 9 all over 11 ampere. So let's return back to the screen to pick the correct answer to this question, and that is option B, 9 over 11 amperes. Question 42. The diagram above shows two capacitors P and Q of capacitance 2 microfarad and 4 microfarad respectively connected to a DC source. The ratio of the energy stored in P to Q is, so let's move over to the board to provide answer to this question. So here we are required to calculate the energy stored in a capacitor. So the energy stored in a capacitor is given as, let's call it E, is given as 1 over 2 CV square. Of course, there are other formulas, but I think there are about 3 of them, right? But the one you use depends on what is given to you in the question. So let's calculate for, first of all, the energy stored in the capacitor P. Okay, so P will now be equals to 1 over 2. Then the capacitance is equals to 2. Then 2 times V square. So 2 we cancel out 2, so that we'll be having V square left. Then let's calculate for the one stored in the capacitor Q. Okay, so this will be 1 over 2 times 4 times V square, and this will be equals to 2V square. But we are asked to find the ratio of the energy stored in P to Q. So P ratio Q will be equals to V square ratio 2V square. So in this case, V square will cancel out V square, so that at the end of the day we'll be having 1 ratio 2. So we can say that the ratio of the energy stored in capacitor P to that of Q is 1 ratio 2. So let's move over to the screen to pick the correct answer to this question, and that is option D, 1 ratio 2. Question 43. The diagram above shows the capacitors C1, C2, and C3, 2 microfarad, 6 microfarad, and 3 microfarad respectively. The potential difference across C1, C2, and C3 respectively are. So let's move over to the board to solve this question. So as we can see from the diagram, the capacitors are arranged in series. Okay, and since they are arranged in series, the same quantity of charge flows through all of them. The 3 capacitors. But remember that capacitance is equals to Q all over V. Right, so in this question we are giving voltage to be equals to 12 volts, right? So first of all, let's calculate the effective capacitance in series, right? So effective capacitance in series is equals to 1 over the effective capacitance in series, which is equals to 1 over, so the value of the capacitors we're giving to us, so here will be 2 plus 1 over 3 plus 1 over 6. Okay, so here we definitely know that the SCM is 1. So at the end of the day, we're having 6 all over 6, which is equals to 1 microfarad. So that is the effective capacitance, right? So the next step is for us to calculate the quantity of charge, okay, that went through the 3 capacitors. So to calculate that, that means we are looking for Q. So we just make Q the subject of formula, so that Q is equals to CV, right? But remember that our C represent the effective capacitance in series, which is 1, and our V represent the voltage. So if we multiply together in this case, we'll be having 1. And remember that 1 microfarad means 1 times 10 raised to power minus 6 farad, right? So in this case, it will be 1 times 10 raised to power minus 6 times 12. So that we'll be having 12 times 10 raised to power minus 6, right? Minus 6 coulomb. Right? Okay. Now we want to calculate for the potential difference across each of the capacitors. Okay. So since we are looking for potential difference in the in this case now, so we'll make it the subject of formula, so that for the capacitance C1, okay, so the potential difference across the capacitor C1 will be equals to V is equals to Q all over C. Right? So in this case, equals to Q all over C1. So in this case, we'll be having 12 times 10 raised to power minus 6 divided by 2 times 10 raised to power minus 6. Right? So 2 here is 1, 2 here is 6. Now remember that if we apply the law of indices here, discover that everything will be equals to 6 times 10 raised to power 0. Right, which is the same thing as 6 volts. Okay, so the voltage across the capacitor C1 is equals to 6 volts. Then we do it for that of C2. Okay, so V is equals to Q all over C2. So for C2, I think that is equals to 6. So here we're having 12 times 10 raised to power minus 6 all over 6 times 10 raised to power minus 6. So the same thing at the end of the day, we'll be having 2 times 10 raised to power 0, which is equals to 2 volts, right? Then we'll do it for the third capacitor, which is, let's do it here, which is C3. So for C3, V is equals to Q all over C3. So we just put in the value 12 times 10 raised to power minus 6 all over 3, right? So 3 here is 1, 3 here is 4. So that we'll be having 4 times 10 raised to power 0. Remember that the 3 here is microfarad. So that we'll be having 4 volts. So let's bring the 3 values together. So the first value is 6 volts, comma, while the second one is 2 volts, comma, while the fourth value is 4 volts, 4 volts. Okay. So let's move over to the boards to pick the correct answer to this question. So from our calculation, we got 6 volts, 2 volts, and 4 volts. And that agrees with option D, 6 volts, 2 volts, and 4 volts. Question 44. The diagram above shows a closed site 0.5 meter in a uniform electric field E in the direction shown by the arrows. What is the flux for the bus? So if you are given questions like this, it's very important that you look at the provided diagram carefully before you answer any question. So if you look at the direction of the field, you see them pointing to the right, then you see another one pointing to the left. Okay, so in this case, you don't have to bother yourself to calculate for the flux, because obviously the flux for the bus here is going to be 0. Okay, why? Because one of the electric field is pointing to the left, which is this arrow. So that makes the correct answer to this question 0.0E. Do you have any question to ask? If yes, please feel free to ask your question by clicking on the link in the description below, and that will take you to my school website. There you can ask all your questions, and our team of solution providers will provide answer to all your questions within a short period of time. Moving on to question 45. In the circuit diagram above, the ammeter reads a current of 3 amperes when R is 5 ohms and 6 amperes when R is 2 ohms. Determine the value of X. So let's move over to the board to provide answer to this question. Now, what you must take note there is that the X there, okay, represents a resistor, and the two resistors are in series, right? So for us to calculate effective resistors when they are in series, remember that will be 1 over R effective. Okay, so let's take it when the arrow there is equals to 5 amperes. So in that case, we're having, 5 ohms. So in that case, we're having 1 over 5, then plus 1 over X, right? So in this case, we'll be having 5 plus X over 5X, right? But we are looking for the effective resistance. So in that case, R effective will be equals to 5X all over 5 plus X. Okay, now let's do it for the second condition that is given to us. Said when the current of 6 ampere flows through it, R is 2 ohms. Now remember, the two resistors are in parallel, so we calculate for, in that case again, we calculate for effective resistance. So in that case, we have 1 over R effective. So here we'll be having 1 over 2 plus 1 over X. So this will be equals to 2 plus X all over, this will be equals to 2 plus S all over 2S, right? So effective resistance in this case will be equals to 2S all over 2 plus X, right? But in this question, we are asked to determine the value of S, and the only way we can determine the value of S is for us to calculate for voltage, right? Now remember that from Ohm's law, voltage V is equals to IR, right? So let's substitute our value. So for here, our effective resistance is 5X all over 5 plus X, right? And the current in that case is 3 amperes. So here we'll be having 3 times 5X all over X plus 5 plus X in bracket. While for the second one, we'll be having 6 bracket open, 2X, okay, 2X all over 2 plus X, right? So let's open the bracket, so that we'll be having 15X all over 5 plus S, while for the second one, we'll be having 12X all over 2 plus X. But in both cases, we are calculating for voltage, so we equate both voltages, so that we'll be having 15X all over 5 plus S to be equals to 12X all over 2 plus X. So we simply cross multiply. So if we cross multiply here, we'll be having 60X plus 12S squared to be equals to 30S then plus 15S squared. So we can simply collect like terms. Okay, so you're having 15S squared minus 12S squared to be equals to 60X minus 30X. So this will give us 3S squared, and here we'll be having 30X, right? So 3 here is S squared, and 3 here, that will give us 10S. Of course, we can bring this to this other side to form a quadratic equation. So that s squared minus 10s is equals to 0. Then we can now factorize. So if we factorize, we have s come out and we have 1x minus 10. And everything here is equals to 0. So remember, this is in a bracket of its own, so that s is equals to 0, or s, what is in bracket here, is equals to 10. So we can say s is equals to 0 or s is equals to 10. But remember that the s represents a resistor, the resistor that we are asked to find the value. So in this case, the value equals to 10 ohms. Okay, so let's return back to the screen to pick the correct answer to this question. So from our calculation, we got the value of the resistor S to be equals to 10 ohms, right? So that makes option C the correct answer to this question, 10 ohms. Do you have better explanation or steps to any of these questions? If yes, you can reach down to the comment section below to comment the question number and the solution you wish to share. Question 46. In the diagram above, determine the RMS current. So RMS stands for root mean square current. Okay, so let's move over to the board to provide answer to this question. Remember that what we have on the circuit or the diagram that we have on the board there is RLC circuit. Okay, so let's provide the answer to this question. So we are asked to determine the RMS current. So RMS current is equals to VRMX, okay, VR, that is RMS voltage all over Z, okay, where Z stands for the impedance of the circuit. But remember that impedance Z is equals to square root of impedance square plus the square of the capacitor, so resistor square. So this is actually LRO circuit, okay, not ROLC circuit. Okay, so let's substitute the values that are given to us. So in this case, we'll be having 3 square plus 4 square, right? 3 square plus 4 square, which is 9 plus 16, and that will be equals to 25. So root 25, that will be equals to 5, right? So we already know our Z to be equals to 5. But in our formula, RMS current is equals to the voltage. So in this case, the voltage is equals to 240. So 240 divided by 5, that will be equals to 48.0 ampere. Okay, so the value of the root mean square current of the circuit above is equals to 48.0 ampere. So let's return back to the screen to pick the correct answer to this question, and that is option B, 48 amperes. Question 47. Find the frequencies of the first harmonics of a piano string of length 1.5 meter if the velocity of the wave on the string is 120 meter per second. So let's move over to the board to solve this question. So here we are talking about vibration in a string, right? So for vibration in a string, the fundamental frequency happens to be equal to the first harmonics, right? And fundamental frequency F0 is given as V all over 2L. So in this case, L is equal to 1.5 meter, while V is equal to 120 meter per second, right? So we just substitute our value. So you'll be having 120 all over 2 times 1.5, which is 120 divided by 3, and that will be equals to 40, right? That will be equals to 40 hertz. Okay, now another thing you must take note of is that since the fundamental frequency is equals to the first harmonics, right? So the subsequent harmonics is just a multiple of the fundamental frequency. So if we are looking for the second harmonics, it will be 2 times the fundamental frequency. If we are looking for the third one, it will be 3 times the fundamental frequency. Okay, so the first harmonics we've already calculated that to be equals to 40 hertz. So the second harmonics will be equals to 2 times 40, right? So remember that here we are dealing with the case of a string, right? And the fundamental frequency is equals to the first harmonic, while the subsequent harmonic is just a multiple of the fundamental frequency, or you can say the first harmonics, right? So if the first harmonic equals to 40, then the second harmonic is going to be 2 times 40, that will be equals to 80 hertz, right? And the third harmonic will be equals to 3 times 40, and that will be equals to 120 Hz, right? So the first, second, and third harmonic respectively are 40 Hz, 80 Hz, and 120 Hz. So let's return back to the screen to pick the correct answer to this question, and that is option A, 40 Hz, 80 Hz, and 120 Hz. Question 48. A bread toaster uses a current of 4 amperes when plugged in a 240 volts line. It takes 1 minute to toast slices of bread. What is the energy consumed by the toaster? So let's move over to the board to provide answer to this question. Now we know that power P is equals to energy consumed, right, or energy expended all over time, right? So in this case, we are looking for energy consumed or energy expended. So let's just call it EE, right? It's equals to power times time. But remember that power is IV. So here we'll be having IV times T, right? So I is given to us to be equals to 4. So we'll put our times here. V is given to us to be equals to 240. And then T is given to us to be equal to 1 minute. But this minute we have to convert it to seconds. So, and 1 minute is equivalent to 60 seconds. So here we put 60. Okay, so here we put 60, right? So 4 times 60, that will be equals to 240. Okay, times 240. Now, 24 times 24 is 576, right? And we have 2 zeros here, so we just put them in front. So that the energy consumed is equals to 57,600 joules, right? But if we look at our option is given in standard form, so we have to put this in standard form. So we just count 1, 2, 3, 4. So this becomes 5.76 times 10 raised to the power 4 joules. So let's move over to the screen to pick the correct answer to this question, and that is option A, 5.76 times 10 raised to the power 4 joules. Question 49. What is the angle of dip at the magnetic equator? So first of all, let's define the meaning of angle of dip. Okay, so angle of dip is the angle formed between the Earth's resultant magnetic field and the horizontal. So this angle of dip actually varies from one place to another on the Earth's surface. Okay, so at the equator, the angle of dip is 0 degrees, while at the north and south pole, angle of dip is equal to 90 degrees. Okay, so the answer to this question is option B, 0 degrees. So the answer cannot be 45 degrees, the answer cannot be 90 degrees, and the answer cannot be 180 degrees. And the reason is because the angle of dip at the equator is equals to 0 degrees. Okay, so that makes option B the correct answer to this question. Question 50. Which of the following graphs correctly represent the variation of mass of a given material deposited with time for constant current in Faraday's law of electrolysis? Okay, so we have to use this graph to answer this question, right? So the first graph here for A represents option A respectively. Okay, for B, the same thing as what we have here. Okay, so for Faraday's first law of electrolysis, we know that mass of substance deposited during electrolysis is directly proportional to the quantity of charge. Okay, so but remember that quantity of charge is equals to IT, right? So we can say that M is directly proportional to IT. But in this question, we are told that I is constant. So in that case, you're having M to be equals to IT, but this is constant, right? So from here, you can see that the mass of substances deposited during electrolysis increases as time increases, right? So in that case, we are going to be having a linear graph. Okay, so at time 0, then the mass of substance deposited will be equals to 0. So as time increases, the mass of substance deposited will increase. Okay, and that makes option A the correct answer to this question. I believe you've learned something from this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly tap on the notification bell to get informed as soon as we release the next videos.